Welcome back, APCSA students. This is a video that goes with Lecture 2 slides. This will be on primitive data types and an introduction to using variables. So we've only seen the string literal and the values that we've been printing so far. You can have different types of data in your program, and this allows you to do different things with the values. So here you'll see these are not inside double quotes, so it's not going to print literally out 35 plus 100. Java actually sees these as numeric literals, and it's actually going to do math before it prints it. So I can show you what these look like when they print out. So this is a different type of data. So if you have numeric literals with no decimal value, then those are integers. If you have numeric values that have decimal values like these do, those are called doubles. And then you can have this, we'll often have these variables that can have two states, either true or false, and those are called Boolean variables. So these are the three main primitive data types that we're going to be working with today and that are on the AP exam. There are, I think, 8 primitive values, and we'll be using these 3 throughout the year. There is another type of data that Java has that's called a reference type, and it turns out this string literal is a reference type of variable. So we'll do a lot more of that in Unit 2 with reference type variables because there's a ton of them. But we only have these 3 primitives that we want to work with, so we want to understand how they work. Primitives and reference types are stored differently. They behave differently. There's different things we can do with them. But the primitives are the easiest to learn because they're primitive, right? In regards to these data types, in our programs, sometimes we want to actually create variables. And so before I go to the receipt, I want to mention this is doing math, right? It's adding 135 and this is subtracting. So we haven't talked about doing math, but I did want you to just recognize that we can do some simple math statements with these numerics. I can't do those with this string value. I can't subtract 5, so that'll give me a compiler error because I'm trying to subtract a value from, but I can actually add. That's the only thing I can do with strings, and all that's going to mean is that I concatenate a value on. So you can see it put the string literal and then it just stuck that 5 right on the end, that numeric literal. All right, so if we had a program, here's a simple program that's designed to show a receipt from a purchase. So it actually looks like this in the slides. So the purchase, there were 3 items, $38, $40, and $30. To get the subtotal of those purchases, we add them together. To compute the tax, we add those items together and multiply by the tax rate, which in this case is 8%. To get the tip, we need to add those 3 things together and multiply by 15%, which we see here. And then to get the grand total, we have to add the subtotal, the tax, and the tip. So what you can see here is there's a lot of code reuse. And so if we later found that it was actually $30.99, and to be accurate and have our accounting books, we need to change all these values to $30.99, I would have to change it here and here and here and here and here, and that's a lot of places to change it. So variables are not only going to help some of this code repetition be handled more simply, it's also going to allow us to change our programs in the future more easily. I'm only going to have to change that 30 to 30.99 in one place. So these are some of the reasons we use variables. So when we are thinking about variables, we want to be thinking declare it, initialize it, use it. So you declare a variable once, you initialize it, give it a value, its first value once, and then you use it a ton. Use it as much as you want to use it. You can give it new values, you can print it, you can use it in an expression. So we declare it, we initialize it, and then we use it. Sorry. So the declaration of a variable, you give it its type. So its type, and then the name of the variable, and then a semicolon. So the type are those three types for now that I mentioned, the primitive types, int, double, and boolean. So here you can see that a variable named x was created as an integer. And then my GPA was created as a double. So just to show you what that looks like, int x, and then it was double my GPA. I think they had it all caps. So this compiles, I've declared two variables, they have no values in them yet. So after we declare our variables, then we can assign them values. The first time we give our variable a value, it is called initializing the value because we're giving it its first value. So if I want to give x the value of 135, and then I want to give my GPA a value of 99.9. How about that? So I've given that variable, those variables, their first values. It's up to me to match the type. So here, 135 is an integer type. Up to me as the programmer to match the types. So there's nothing wrong with this. I haven't used these variables yet. I've declared them and I've given them an initial value, but I just want to show you I can't assign an integer value or a double value to an integer variable. So it's up to me to keep those types matchy-matchy. So either I change that variable to a double or I get rid of the double there. I can, and I'll show you this, I can assign an integer to a double, but it will actually store it as a decimal value. So it will put a 0.0 on it and it will store it like that. Whereas this is just stored as a 135 with no decimal value at all. So these types matter, and we'll see even more later with calculations, they matter a lot. So remember, it's up to you to match your variable type with the values you try to put in it, and the compiler will let you know. So these are some more examples of assigning data. When we use the variables, we can do lots of things with them. So I've declared it, I've initialized it with the initial value, and now I can print it. So here's an example of a print, and here's an example of using that plus sign to concatenate. So x is the string literal in quotes, that will print out literally, and then here's the variable x, and Java will actually go and get the value of that variable to print out. Here we're doing a bunch of math, so Java will do the math because it can, and it'll do 5 times 3, and it'll subtract the 1, and it'll print that value out. So this is the output from that that's displayed. Here we can see that we declared it, we initialized it, and then we give it a new value. So we did some math on it, and so now it's got this new value. Did I go too far? Give me a sec. Okay, this is, so we can combine the declaration and initialization step before we use a variable. So it's since we have to declare it once and initialize it once, we sometimes combine those into one. And so that would simply mean that instead of saying int x equals, or int x, I would say int x equals 135 here. And I would give this my GPA value as well here. And then I don't need these. This has already happened, so I can comment those out. So you can combine them. you need to remember in your mind that it is actually two statements in one always. You are declaring a variable and you're initializing it. And the reason you want to do that is because when you go to use it later, you want to make sure you're not redeclaring it. So we declare it once, we give it its initial value of 3, and then notice here I'm assigning it a new value, but I didn't redeclare it. You declare once, you initialize once, and then you use it however much or little you want to, giving it new values, printing it, using it in an expression. Okay, so it's important to remember that that declaration only happens once. So one way to remember this equal sign when we're assigning values is to use in your head the term gets the value. It's not a mathematical calculation. So here you can see I've declared an integer value x, and x gets the value of 3 for its initial value. And then here, x gets the value of x plus 2. So what is x at this moment in time? So we solve the right-hand side, and x at this moment in time is 3. I add the 2 to it, and I get 5. And so now that same variable x gets the value of 5. This is not a mathematical equation where we subtract x from both sides or we're trying to solve for anything. We have variables, these storage containers, that are holding values for us, and we want to sometimes put new values into them based on new information. So the same way I can combine that declaration and initialization, I can combine a lot of declarations and I can combine a lot of initializations. I can also combine both. So here you can see 3 variables are being declared as x, y, z. And here I'm not only declaring 3 variables a, b, and c, I'm also giving them new values. So these are different ways you can reduce the number of lines in your code. So you can list all your integer variables together, either declaring them all or declaring and initializing them all together. So as I mentioned earlier, it's up to you to match the data that you're putting into a variable with the type of the variable. And these are some common errors you can get. Here is kind of that flip-floppy. So when you're assigning a variable a value, the variable's always on the left. So the thing on the left is going to change. I can't change a 7 to be x, so it should have been x equals 7. Also, you will sometimes get the variable hasn't been initialized. So I've made a variable x and now I'm trying to print it out and I've not given it its initial value. So that can flag an error in the compiler. And then again, I said you declare a variable once. So here you can see that the variable is being declared a second time right here, and that will give you an error as well. So let's see some of those. So here I had already declared int x, and let me just give it a, so maybe I wanted to change it to the value of 47. So already defined. So already defined is your key for declaration. So get rid of the declaration. It's already been declared up here as an integer. I only need to declare it once. So it might help if I print out x and my GPA here. So we can see that 135 is gone, and that 135 is gone forever. Remember, Java works sequentially, and so as we're going down, x now gets the value of 47, and that 135, we didn't need it, so that 135 is gone. And again, if I were to try and print x, and I hadn't given it a value at all, x might not have been initialized. Remember, that's that initial value. So I have a little bit more that I'll add to the next video, a little bit more on variables and naming conventions. So I'll see you then. Happy coding.